So this question is testing what is meant by and our understanding of what is meant by the product moment correlation coefficient. What did it actually measure? So to answer the question straight away, the product moment correlation coefficient measures how close the points are to a straight line. This is linear correlation. Now we've got three negative correlation coefficients. We've got one which is fairly close to zero, and then two which are positive. So the negative graphs, the negatively correlated graphs, are A, this is negative, B, which is negative, and E, which is negative. Those are the ones that are clearly negative. F is clearly positive. We can imagine a line going through those points there. What about C though? Is C close to zero, or is it more positive than that? Well, if you look at graph D, that looks pretty close to zero to me. There doesn't seem to be any correlation. I wouldn't, if I didn't have any numbers, I wouldn't necessarily be able to say whether they were positively or negatively correlated. But what about C? I mean, there seems to be an awful lot of correlation, but not to a straight line. It looks as if it might be some kind of quadratic. But if you think about a straight line, that you tried to get the straight line as close to those points as possible, it's likely that it's going to be something like that. So that one would be, in my book, positively correlated. So let's put some numbers on this now. The negative ones first. Well, we've got A, B, and E, which are all negatively correlated. Which one of those shows the points closest to a straight line? Well, to me, it's fairly clear that A is the graph which has got the minus 0.99 correlation coefficient. B is not quite so closely correlated to a straight line, but it's certainly closer than E, because E's got these outliers here. So E looks as if it's not quite so well correlated as B. So I would put minus 0.8 here and minus 0.6 here. D is the one which is close to zero, so that's the 0.1. And the two that are positive, and the one which has got the most correlation is F, which is 0.8, and then 0.5 is the figure for C. So just confirming those are the figures there. But isn't it interesting that if we didn't have the graphs and we calculated a correlation of minus 0.6, for example, we might say, oh, we've got a lot of correlation there, that's significant correlation. But until we draw the graph, we don't actually see the outliers. So it's always good to draw a scatter graph before actually confirming the correlation by calculating the PMCC. Similarly with this graph here, just because we get a correlation coefficient of 0.5 doesn't mean to say that a linear graph is the best correlator, best model. So there we are, that's the answer to that question.